Hello friends, this question is from the test series number 11 from the subjects of analog and topic name is DC biasing BJT. In the question, we have a combination of two transistors and two diodes. And the question says that in the level shifter shown, calculate the value of R, resistance R, for V0 to become 0. Assume that internal drop across the diode VD and VBE2 is 0.7 and HFE is very high, means beta is very high. So if the diode potential is given as a 0.7, so I can redraw this part of the circuit here as, because each of my diode will going to act like a 0.7 volt battery, so I can redraw it as a 0.7 and 0.7 is going to same as a 2.2k, and I know that base 2 emitter is again a 0.7 because base is positive. So here we have one more battery of 0.7 volt, base 2 emitter one, and then we have a resistor of in the value of 0.27k, and here we have a supply of minus 12 volt. So if I may apply the KVL here in this loop, because we have formed the loop here, it's a closed loop. If I may apply the KVL here, so my KVL equation must be equal to from here 0.7 plus 0.7 minus VBE minus IE into RE is equal to 0. Why IE? Because this 0.27k is connected to the emitter terminal, so current flow across the emitter terminal is IE, so this current must be equal to IE. So from this value, this VB is again equal to 0.7 only. So from this equation I can get the value of IE as equal to 2.6 milliamp. So my emitter current is 2.6 milliamp. So now if I may focus on the transistor number A, okay, so in the transistor A, the base terminal has a potential of plus 8.6 volt. 8.6 volt is directly attached to the base terminal, so my VB will be equal to the 8.6 volt. So now if I may assume that the base 2 emitter for transistor 1 also equal to 0.7, again assuming that it is an active region. So if the base 2 emitter voltage is again 0.7, then my emitter voltage must be, because my VB is what? VB is VB minus VE, which is equal to 0.7. So I know that VB, it is equal to 8.6 volt. I know this value, so only unknown is VE. So I can calculate my VE, which comes out as 7.9 volt. So my emitter voltage is 7.9 volt. So current across this terminal is a IC2, collector current of the second transistor, because this resistance R is connected to the collector terminal of the second transistor. Because the HFE is very high, so the emitter current of the second transistor must be equal to the collector terminal of the second transistor, and we know that current always flows from high potential to lower potential. So current across the resistance R can be expressed as IC2 is equal to, which is eventually the emitter current of the first transistor, is equal to the VE minus V0 V1 minus V0 upon R. And what the question says that find the value of R under the condition in which V0 is equal to 0. So we need to find the value of R for which V0 is 0, and we have know that IC2 is equal to IE1, which is equal to 2.6 milliampere, and we have just calculated V as 7.9 volt. So now only unknown the equation is R. So this equation is 2.6 milliamp is equal to 7.9 upon R, or my R is basically equal to 3.04k. So resistance comes out as 3.04k. So here my correct option is option A. Option A is my answer. Thank you.